Welcome back to another video, and today we're going to be taking a look at my calculus book from like 2 years ago, from 2021. We got the difference quotient. I remember writing that. And here we have graphs and limits. And then when limits fail to exist. I'm going to go a little faster on these. Remember the limit laws? The squeeze theorem, man, these bring me back. The reason I'm going over this is because like I'm taking physics and you need to know Calc 1 and 2. Limits using algebra. That was a whole lot of work right there. The rational functions and graphs. Remember doing that? Whole lot of canceling. VA, all other x's, the vertical acetome, horizontal acetome, looks at highest power term of both. All other x values other where the denominator is 0. What is this? HA rules. Oh, I remember that. Yeah, let me see. Oh, so like if you notice here, like the handwriting is like a little different because like my shoulder came out again. And I had my little sister do this. Limits of infinity and graphs. And then I just decided I was going to start writing myself again. So there was 7-121, 7-121. I don't know why, but I started writing here myself. Limits at infinity and algebraic tricks. What are the rules? Continuity at a point. I remember that. Continuity and interval. Intermediate value theorem. I don't remember what that is at all. Right angle trigonometry review. Yeah, I remember that from the previous class. So this was like a little bit of Calc 1 and trig combined. Sine, cosine, and special angles review. Just more review. Unit circle definition and sine of. I was never good at the unit circle, man. I don't know why. I couldn't remember it. Properties of trig functions. So I even the even and odd properties. Cosine negative theta equals cosine theta even. Sine negative theta equals minus sine of theta. Wow, man, these are bringing me back. Graph of sine and cosine. So this is the sine function all like lazily drawn. And this is the sine function, this is the cosine function. What is this? Graphs of sine. What does it say? Graphs of sine use. I can't even read that no more. Graphs of tan, secant, cotangent, and cosecant. Solving basic trig equation. I feel like I did this the year before. I was just reviewing it. Derivatives and tangent lines. Oh, I remember this. I was so excited because I wanted to know what a derivative was. And then I finally learned it here. Let me see what the definition is. Derivative of function y equals f of x at an x value a. F prime of a equals the limit as x approaches a. F of x minus f of a, x minus a. Wow. And here's like the actual definition. I wrote it once here and I wrote it once here just to be sure because I knew this was important. Continued. So I have f prime of a equals the limit of h as h goes to 0, f of a plus h minus f of a over h. I remember solving derivatives using the actual definition, and then we learned like the derivative rules, and then it got much simpler. Yeah, what is this? Computing derivatives from definition. Yeah, there it is. It was a lot of work. Interpreting derivatives. I don't remember much of this at all. Continue, and I guess it was enough where we had to do 2 pages. Derivatives of function and graphs of derivatives. I don't really remember much of this either. I remember there was like a hole, if it doesn't exist somewhere. The derivative as a function. Don't really remember too much of that. Prove that if derivative functions are continuous. I guess I didn't prove it. I just left it. Power rule and other rules for derivatives. Yeah, this is where I started like getting into it because it made it so much easier. Let's see the derivative of a constant c. F of x equals c. Derivative of f of x equals x. F prime of x is equal to 1. So derivative of f of x equals x. F of x equals c. Okay. Oh, because it's just like a straight line c. We have that. Derivative of a constant multiple. So we can just pull the constant multiple out and just find the normal derivative. The power rule, I love the power rule, man. Everything's so much simpler. I thought I was a math genius when I learned the power rule. And derivative of a sum. So you break it down, you find the derivative of f of x plus the derivative of g of x. And if a difference, you do the same thing. Trig identities, I remember these. These are really useful. That's why I put them in a box. Angle sum and difference formulas. Also useful. Also put them in a box. The double angle formula. I remember using these. I remember these from trigonometry. And then we have higher order derivatives and notation. Don't really remember this at all. Oh, okay, I remember this. The first derivative, second derivative, and nth derivative. Remember that? Oh, I love the derivative e to the x. So I guess, so the limit of, as n goes to infinity, 1 plus 1 over n to the n equals e. I just remember e to the x, which is e, the derivative. Yeah, e to the x equals e to the x. What is this? E to the x equals 0. And then find a derivative. So x was a constant, and then e squared. And then e to the x squared. Power rule, bring e. I remember, oh man, I remember doing all this. Proof of the power rule difference and constant multiple rule. I guess I proved them? That just looks like the definition again. Product rule and quotient rule. What is the sum rule? Okay, I remember that. Difference rule and the product rule. So derivative of f of x times g of x equals a derivative equals f of x times the derivative of g of x plus the derivative of x times g of x. And here's the quotient. So the derivative of f of x divided by g of x. It's going to be g of x, the derivative of f of x minus f of x, the derivative of g of x over g of x squared. Good times. Derivative rules. I guess I rewrote them. Derivative of constant, f of x equals just c. Derivative of f of x equals x. And then d of x equals just 1. The power rule, constant multiple, derivative of sum, difference. So I guess I was just rewriting like everything I know so far. It's pretty cool. Special trigonometric limits. Don't remember anything about this. Composition of functions. Oh, it was like g of f of x or something like that. Some more review. Solving rational equations. I think I solved one. Derivatives of trig functions. Oh, these are useful. How would I say? Derivative of sine of x equals cosine of x. The derivative of cosine of x equals minus sine x. Yeah, these were useful. I boxed them all. The thing that I wrote were each of them is like positive or negative. Yeah, I did. Or sine, cosine, everything's negative. Rectangular motion. Don't remember anything of this. Logarithms from like algebra 2. Some more review. L of x means natural log. Log base e of x. Log x means base 10x. It's called the common log. Man, this is fun learning all this math. Log function of the graph. Don't remember anything of that. Rules for combining log and exponents. Remember a little bit of this. So the log rule. Log base a of a to the x equals x. Don't remember that. I don't think I'm even saying them right. Review of exponent rules. Yeah, I remember this. This was like basic algebra. Oh, the chain rule. I used to suck at the chain rule until I made a video about it, and then I understood it. So it's f of g of x. Wait, how does this work again? F of g of x. I don't remember. Wow. It's f prime of g of x. So this is composition of functions, and that's just I'll find the derivative. So it's f prime of g of x times g prime of x. So it's dy dx equals dy du. Wow, I need to review this for actual, like, for physics. I don't really remember this at all. I never made a video about it. I'm going to rewatch my own video because it did help. So more chain rule. What is this? Implicit differentiation? Don't remember that. Derivatives of exponential functions. So it's right here. D of x, the derivative of a to the x equals a to the x times natural log of a. And then x to the a equals a times x to the a minus 1, just the power rule. Derivative of the log function. Did I just write that? No, I didn't. So log base a of x, okay. It's all right here. I need a review. Inverse functions, I was from, I think from algebra 1 or 2. And then I wrote it down. Reverse x and y, solve for y, change y to f prime. No, to f of negative 1. Inverse trig functions. Derivative of inverse trig function. Related rates. Don't remember this at all. Solving right triangles with more trig. Max and minimum values. First derivative and second derivative. Guess we were testing for first, second derivative. Extreme value example. Don't remember that. The mean value theorem. Don't really remember that either. Polynomial and rational inequalities. Derivatives and shape of a graph. I kind of remember this. Linear approximation. Don't really remember that. More linear approximation continued. The differential. Oh, remember that. I could never say this guy's name wrong. It's L'Hopital's rule. I remember learning that. I was so excited to use it, and we almost never did. Newton's method, don't remember that. Newton's method, an example, okay. Oh, antiderivative, just going in reverse of the derivative. Continued. Oh, summation notation. I hated this because I could never draw that little sign. I started it off, this is the sigma notation. I started it off like this, and then it ended up like that. And then it would just get worse and worse and worse. Approximating area. Ooh, it's just part of the integral. We'll use little rectangles to approximate the area under a curve. And then we learned we could do that with the integral. Approximate area continued. The fundamental theorem of calculus. So I remember this. I know there was a part 1 and part 2. If g of x equals the derivative of, not the derivative, the integral of a to the x, f of t dt is g prime of x, f of x. I just think it's like, if I remember right, it's the derivative going backwards. What does it say? The derivative of the integral of a function is just the original function. Yeah, it was just going in reverse. And then here's some examples. Now, these were fun times right here. Let me see if I can remember this example. So equals x squared plus 3. Plug in x for t. So we just plug in x, okay? What is this? We just plug in x for t. What is this one? Don't remember that. Okay, review. The fundamental theory is calculus part 2. So what is it? When f is any antiderivative of f is a function so that f prime equals f. So f of x equals f prime of x. So the integral of a to b, f prime of x dx equals f of b minus f of a. The integral of the derivative is the original function. And then the example, and then the substitution method, I remember that one pretty clearly. Skip a page. Average value of a function. I'm not sure if I'm at Calc 2 yet. I don't know if I enabled it. 4 ways to represent a function. Verbally, algebraically, visually, with a graph, numerically. Okay. Mathematical models. I'm just drawing graphs. More mathematical models continued. The formation of functions. Don't remember what that was about. Exponential functions. Sounds like more algebra. What does it say? Inverse functions and logarithms. We already learned about that. Continued. I think I was drawing a circuit for one of my classes. I could not remember what this is anymore. I just knew I drew it. What is this? Polynomial function differential. All differential functions are continuous. Therefore, all polynomial functions. Oh, this is discrete math. I remember this. So the limit of a function. What is this? Direct substitution property. Limits and horizontal asymptotes. Derivatives and rates of change. This might be Calc 2. Derivative polynomial exponential functions. Trig functions. There might be more review. The chain rule. Okay. So the inside out rule. This, I was watching like a video by nancypi, and I decided to remake it so I could remember. So you take the derivative of the outside function and leave the inside alone. The outside would be 7 to the 6. And then the derivative of the inside function, which would just be 3. X is a constant, and then 1's also a constant. So it would be 7 to the 6. And then you could use the power rule. So you would get 21 to the 3x plus 1. Did I do that right? The inside function. Well, I don't think I did that right. Derivative of the outside function, leave the inside alone. Oh, times the derivative of the... Okay, I get you. Implicit differentiation, don't remember that. Derivative of the log function, okay. Rates of change in science. Linear approximation. Hyperbolic functions. Max and minimum values. The mean value theorem, don't remember anything of this. What derivative tells about the shape of a function? Don't really remember that either. There's L'Hopital's rule again. L'Hopital's? I think I'm saying that right. Sketching a graph. What is this? Oh, this is in pen. This is fancy. Oh, this is how we find the antiderivative of 1. We just add like, it's going to be x plus c. Okay, I remember this. Area and distances. The Definite integral. I remember when they would first teach us the definition, we had to use the actual definition. The definite integral continued. The properties of definite integral. So I don't really remember this at all. If a equals b, then delta x equals 0. Wow. Fundamental theorem of calculus. I guess you just plug in x. Fundamental theorem of calculus part 2. Oh, so you plug in, oh, I remember this. So you plug in, find the antiderivative, then plug in a and b. Yeah, past Ruben, thank you for teaching future Ruben how to do this part. Let's see some example. So y equals 9 to the tangent x, let u equals, is this u substitution? Like, I need to get better u substitution. I wasn't very good at it. Then definite integral. Ooh, the substitution rule, I remember this. U substitution. Okay, pick the inside function, take its derivative. So the inside function would be x squared plus 2. Take its derivative. 2x squared. Wait, 2x. So 2 is a constant. So it's 2x dx. Divided by 2. 1/2 du equals x dx. Sine u times 1/2 du. I kind of remember this. I just can't explain it to you. I just got to rewatch like a video. What is this? Every way to find a derivative. So I guess I was taking notes for like the final here, and I wrote it all down on one page, just so I could have it. Continue again. Finding the integral is just taking the antiderivative. Part 1. G of x equals, I don't remember how to say this. The integral of a to x, f of x dt, you just plug in x. Here's an example. So we have t squared plus 3 dt equals x squared plus 3. I guess you just plug in x. Part 2. Take the antiderivative and then plug in b and a. So here's an example. We take the antiderivative, which would be this, and then we just plug in b and a. It can be f of 2 minus f of 5. And then, how do we do this? Plug in f of 2. What is f of 2? So I'm guessing this is f. And we plug in 2 for this into the x, and then minus f of 5. Yeah, I think that's how you do it. U substitution. Pick u expression with pick the longer one. Find a u with respect to x. In a perfect world, u is the inside function, du is outside function. I remember this. U substitution continued. The area between curves. Volume of solids of revolution continued. Wasn't good at that. Volume using cross sections. I wrote one like sentence. Arc length, wasn't very good at that. Work from physics. I'm gonna need that. Oh, now we're at Calc 2. Average value of the function. Integration by parts. I remember that. Only trig identities you need for more notes. Integrals of trig functions, all powers, sine and cosine. This was from 12/21/21. It's almost Christmas. Special trig integrals. Integrals of rational functions. Oh, I remember the improper integrals. What is this? Sequence definitions and notations. More sigma notation. Convergence of sequences. Area between curves. Calc 2. Volumes. Definition of volume. Work. This one from physics. Then one line. Average value of a function. Average equals 1 b minus a, the integral of a to the b, f of x dx. Integration by parts. Trigonomic integrals. Trigonomic substitution. Integration by partial functions. I remember doing this. Approximate integrals. Kind of remember that. Improper integrals. I feel like we already did that. Arc length. Area of a surface of revolution. I'm not doing much of these. Applications of physics and engineering. I'm gonna need that. Sequences. Convergence of limit exists. Divergence. Limit does not exist or oscillates. Theories. The integral. Test Calc 2. Oh, the integral test. I thought it was a test. The comparison test. alternating series test, ratio and root test. Someone's trying to steal a car outside. We're going to keep going. The power series, representing a function as a power series. I can't even say that. Parametrically defined curves, paper exam. Was it just as an exam I did? I don't remember that at all. Polar coordinates. I remember polar coordinates in algebra 1 and 2. Is that it? I think that might be it. This looks like more discrete math. Or, I don't even know what this is. We need to prove P of 0. What is this? 20th century. This is my art class. Oh my god. That looks like that's it.